Hey, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on sets and Venn diagrams. What we'll learn in this video are tools we can use for probability calculations. But first, let's look at what we mean by set. So a set is a collection of objects. I could talk about the set of all students at Marist. I could talk about the set of all prime numbers or whatever. Sometimes things will be in more than one set. So that's when it's helpful to draw a Venn diagram. So a Venn diagram looks like this. It's got a rectangle and it's got two circles that represent sets. We usually call them A and B. So in the rectangle is all of the objects in a particular category. So let's say we're looking at numbers from 1 to 10. So let's let A be the set of numbers 1 to 10 that are even, and B be the set of all numbers 1 to 10 that are prime. So let's fill this with the numbers 1 to 10. So set A, even, includes the numbers 2, 4, 6, 8, and 10. B includes the prime numbers, so we're looking at 2, 3, 5, and 7. So what goes outside the circles are things that are neither. In this case, we'd put numbers that are neither even nor prime. So 1 and 9 are those numbers. Now notice that we have 2 in both A and B. So rather than write it there, let's get rid of it. What we will do is we'll put it in the middle here. This bit here is the overlap of A and B. It is things that are in A and also in B. So that is a Venn diagram. But rather than writing everything that's in A and everything that's in B, it might be easier just to put the numbers that are in each set. So in a Venn diagram, we have two sets, which we call A and B. So once again, we're going to have A be the even numbers, B be the prime numbers, and we're just looking at numbers 1 to 10. So instead of writing 4, 6, 8, and 10, we might just put a 4 to indicate there are 4 numbers here. There's 1 in the middle, 3 here, and 2 that are outside. Know that 4 plus 1 plus 3 plus 2 is 10. So every Venn diagram has 4 numbers. So, of course, this number here indicates the number that are in A only. They are the numbers that are even, but not prime. This number in the middle indicates both. And then, of course, we have the numbers that are in B only, and then the numbers that are in neither. They are the 4 possibilities for the numbers between 1 and 10. They can either be even but not prime, prime but not even. They can be both even and prime, or they can be neither. So that's what Venn diagrams look like. So what we're going to do from now is we're going to write the number that are in each set. But let's look at, firstly, some notation. So just this middle part, which is the area that is common to both A and B, that includes things that are in A and also in B. So we write this as A, and this little symbol means intersection B. So we read this as A and B. It's in both A and B. So everything that's in the circles, that includes everything that's either in A or B or both. And that is the opposite symbol, AUB, A union B. And we read that as A or B. So make sure you know these symbols. So the other symbol we need to know before going on is the not symbol. So let's draw another Venn diagram with A and B. So if we want to look at just this one here, we're just colouring in the things that are in B but not in A. Write this as B and A with a dash. So this A dash means not A, or A complement. Another way you'd read this is, of course, B only. So it's important we know these 3 symbols: intersection, union, and not. So let's look at doing some probability calculations. Please pause and copy these down if you need. So we have a Venn diagram at the top displaying 2 sets, A and B, and the numbers in each set, either set, neither set. We're going to calculate each of the probabilities below. So this first probability says probability of A. So when we're finding the probability of A, we need to include this and this because they are within the A circle. So there are 12 in A. The total number is 7 plus 5 plus 3 plus 9, which is 24. So the probability of being in A is 12 over 24, or a half. If you're giving the answer as a fraction, it should be simplified. It's okay if you want to give it as a decimal too, that's fine. So the next one is probability of A and B intersection. So we're just looking at this section now. So there are 5 in that section out of 24 in total. That's our answer. Notice when asked the probability of something, we are giving a number between 0 and 1. So the next one is the probability of A or B. So remember, union includes everything in the circle. 7 plus 5 plus 3 is 15. So there are 15 inside the circles. And of course, we can simplify that to 5 over 8. So the next one says, what is the probability of not being in B? So we go to our Venn diagram and find the ones not in B. Well, these 7 are not in B and these 9 are not in B. So there are 16 that are not in B out of 24 in total. And we can simplify that to 2/3. So the last one here says, what's the probability where not B and not A? So we have to not be in B and not be in A. We have to have both of those things. So we can't include the 3 because that's in B. We can't include the 5 or the 7 because the 7's in A, the 5's in both. It's only these 9 out here. So the answer would be 9 over 24, which is 3 over 8. How easy is that? Now we're going to look at how Venn diagrams really would help us solve some probability questions. Please pause and copy this down if you need. So let's look at this example here. We've got a class of 30 students, 18 play AFL, 14 rugby league, 7 neither, and we're going to calculate some probabilities. If I select a student at random, we'll find the probability they play AFL but not rugby league, play AFL or rugby league, and then we'll do this extra question that if I select someone who I know plays AFL, we'll find the probability they also play rugby league. Okay, so there's a lot going on there, but Venn diagrams will make this question a lot easier. So how do we know this has to do with Venn diagrams? Well, what we're looking at is where we have like 2 different sets. So we have a set of people playing AFL and also rugby league. So students can be in one of those sets, both of those sets, or neither. So Venn diagrams will help us with the probability. All they do is help us organize our information. We'll organize how many people are in each set, both set, neither sets, or whatever. So let's draw our Venn diagram. So it always looks like this, a rectangle, and then we have 2 circles representing the sets. So let's say we have sets A and B. I need to say what they are. So A will be the set of people that play AFL, and B will be the set of people who play rugby league. So remember, as I said in previous slide, there are 4 numbers that go here, 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 and here. We just have to fill out those 4 numbers, and then the probability calculation will be easy. So hopefully you're a bit confused because you're saying, well, if 18 play AFL, 14 play rugby league, and 7 play neither, that actually adds up to 39. How does that work when we had only 30 students? Well, of course, some could be both. They could have been included in the 18 that play AFL and also the 14 who play rugby league. So this adds up to 39. We've double counted 9 students in AFL and rugby league. So there must be 9 students who play both. So we're going to put a 9 in the middle. However many you've double counted, that's how many go in the middle. If these numbers added up to 41, we'd put 11 in the middle. So we overcounted 9. There must be 9 who play both. So we know that there are 18 who play AFL. So there should be 18 in this circle, the AFL circle. We've already got 9, so we put another 9 here. Similarly, there should be 14 in the rugby league circle. We've already got 9. We need another 5. So what goes outside the circle are the 7 who play neither. They're not in the rugby league circle. They're not in the AFL circle. So to check if we've done something right, these numbers inside the Venn diagram absolutely should add to 30. So 9 plus 9 plus 5 plus 7, in fact, does add up to 30. We've done something right. So we're not done. We haven't answered the probability questions, but we've just made them a hell of a lot easier. So what's the probability a student plays AFL but not rugby league? So we can just simply look at these 9 students here. They're in the AFL circle, but not the rugby league circle. So there's 9 students out of 30 in total, which is 3 over 10 or 0.3. What's the probability a student plays AFL or rugby league? So or means it includes both. We're looking at the students who play AFL or rugby league or both. We include these 9, and these 5. 9 plus 9 plus 5 is 23, so we're talking 23 out of 30. So note, whenever we say A or B in probability, we mean A or B or both. You always include the middle unless the question specifically asks you not to. So, that's those ones done. Now let's look at the other question. If I select a student at random who I know plays AFL, what's the probability they also play rugby league? So I'm telling you, I know that they play AFL. So I know that they're in this circle. So if I pick a student at random from this circle, what's the probability they play rugby league? Well, there are 18 in this circle, 9 plus 9. 18 AFL players, and of those 18, we figured out 9 play rugby league. So my chance of picking someone who plays rugby league is 9 out of 18 or a half, and we're done. That's how Venn diagrams can make probability calculations so much easier. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.